Good morning, Trig. How's it going? We're gonna actually move on and move ahead with these 2 snow days, but we can only practice what we know so much, so we need to know more. So that's what this is about. We're gonna go to 4-4, and 4-4 deals with trig functions of any angle. We've been dealing with 30s, 60s, 90s, and 45s basically the whole time around the unit circle, but we know life isn't just made of 30s, 60s, 90s, and 45s. So one of the good things that I like about this section is the way I teach this and the way I stress SOHCAHTOA over rote memorization. We've already done all this. This is just a new angle at things we already know. So it should be a nice, I think it's a good lesson to do remotely. So without further ado, let's take a little note. If you're a note taker, be my guest. If not, just follow along. Wrong one. Here it is. So 4-4, trig functions of any angle. So I'm just going to start you off with an example problem, right? We go through the example problem. We learn how to do the example problem. We learn how to do this kind of stuff. So here's the example problem. It says, the terminal side of a standard position angle passes through the point -3, -4. I don't know. I don't have a -3, -4 triangle. So that's why this is going to be a different angle, but that's okay. We don't even, not even asking for the angle. It says to find the cosine, sine, and tangent for whatever angle is made. Eventually, we'll go through how to find the angle, but for now, we're just looking for the sine, cosine, and tangent. Okay, so I have standard position angle. It's starting at 0, and we're rotating counterclockwise until we get to the point -3, -4. So here's a picture of the problem. There it is. We're passing through the point -3, -4. There's our angle theta. We want to find the sine, cosine, and tangent for that angle. Well, we kind of already did this with the unit circle stuff. I need to use SOHCAHTOA to find sine, cosine, and tangent. I need a right angle. So to do this, we can either go up or we can go down from this point -3, -4 and make a right triangle, right? We're using Cartesian coordinate plane. So going down doesn't make sense. If I just draw a line down from that point, I'll never get a right angle. So the answer is up. So we go up. We get what's called a reference angle. This is phi, P-H-I, that's our Greek letter for a different angle. But that's okay. The only difference between finding the sine, cosine, and tangent for theta and finding the sine, cosine, and tangent for phi are the signs. And so I've handled the signs by saying, well, if I go to the left, it's -3, because this is the point -3, -4. So -3, -4. We do the Pythagorean Theorem, just like we've done problems just like this so far. A squared plus b squared equals c squared. And we get a really, really famous right triangle. It's called a 3, 4, 5 right triangle. Awesome. From here, we want the sine, cosine, and tangent of phi. That will give us the sine, cosine, tangent of theta because we've handled the sine. So sine is -4/5, opposite over hypotenuse. Cosine is -3/5, adjacent over hypotenuse. And then the tangent is 4/3. A -4 over a -3, a negative over a negative gives us positive. Easy peasy. We like this. Chapter 4-4. Awesome. There is a couple generalizations we can make, and that's what our next note is going to be. First of all, let's look at how we got R if we have this point with the Pythagorean Theorem, a squared plus b squared equals c squared. That's always going to be positive. We're not going to, the radius of a circle, and I mean, that's kind of what we're talking as we go around, wrap it around a circle. It's never going to be negative. That's why we call it R. It's a radius. And we get it from the Pythagorean Theorem. So it will always be positive. Now, because of that fact, we can actually know our positives and negatives for sine, cosine, and tangent just based on what quadrant we're in. If R is always positive, which we just said it is, we know what sine, and I don't mean S-I-N-E, I mean like positive or negative for all of our trig functions just based on what quadrant we're in. Think about that first quadrant. Any triangle you draw in the first quadrant, any triangle I draw in this first quadrant, is going to go over to the right positive, is going to go up positive, Pythagorean Theorem positive, everything's going to be positive. Sine would be a positive over a positive, cosine a positive over a positive, tangent a positive over a positive. So anything drawn in this, for any triangle drawn in this first quadrant, everything is going to be positive. And we can kind of continue that logic, and we get this little table, if you will, and there's a little acronym that goes with it. So first of all, let's talk about what this table means. If you draw any triangle in the first quadrant, sine, cosine, and tangent, all of them, that's what the A stands for, all of them will be positive. Okay. any triangle you draw in the second quadrant, okay? If I draw any triangle in here, I will have to go up, so the opposite side would be positive. I have to go to the left, so the adjacent side would be negative. And then if you kind of apply the SOHCAHTOA stuff to those positives and negatives, you're going to get this. Sine will always be positive. Opposite and hypotenuse would always be positive. Cosine would be negative. Tangent would be negative. So the only one that's positive here is sine, and that's what the S stands for. So these letters here, A, S, T, and C, they actually represent which ones are positive in these quadrants. They are all positive in this quadrant, 1. Only sine is positive in this quadrant, quadrant 2. Well, and cosecant, but we'll get to that. Only tangent is positive in quadrant 3, and only cosine is positive in quadrant 4. Okay? And the last little, the acronym for this is all students take calculus. That's how we can remember that. All students take calculus. I've heard all swimmers taste chlorine. I'm sure there are other more creative ones, but the all students take calculus is the one that I think I got when I was in high school, and I still remember it, okay? The last little bit that I was talking about the reciprocal functions, just because I only wrote sine, cosine, and tangent, it still applies to those reciprocal functions. So whenever sine is positive, cosecant is positive. They're reciprocal functions. Whenever cosine is positive, secant is positive. Whenever tangent is positive, cotangent is positive. So we actually have all those other ones up here as well. Hopefully from your bell work too, we can also apply that. We learned a little fundamental identity that said tangent is always the sine over the cosine. So when we look at this, it also, and it comes all from the same spot, but sine over cosine, a positive over positive, positive. Sine over cosine, a positive over a negative, that would be a negative. Sine over cosine, a negative over a negative is a positive. Sine over cosine, a negative over positive is a negative. So just a different way to attack it. You really then, if you remember the sine over cosine is tangent, need to know the sine and cosine for each one. And then you could figure out tangent. Okay, well, let's put this to some use. This will be the last little example. You saw nothing. The little example of this video. And then I have a couple more on the second video. So what quadrant would I be in? What quadrant am I in if I know the cosine and the cotangent are negative? Cosine and cotangent are both negative. What quadrant would we be in? This question, like what quadrant am I in, will come up a lot when we go to chapter 5 in a little bit, because we end up drawing triangles and solving equations, and one of the first things we'll ask ourselves is, well, where is it positive or where is it negative? So it's a good idea to start getting this table down. So cosine is negative is the first thing I read. Okay, so cosine is negative in these two. Another thing with the unit circle, we can kind of remember cosine is always the x-coordinate. Well, when is the x-coordinate negative? Over here. Anytime I go to the left, the x-coordinate is negative. Next one was, when is the cotangent negative? Okay, so cotangent follows tangent. So tangent's positive here, so cotangent would be positive here. It can't be this one. Tangent's negative here, so cotangent is negative here. Cosine and cotangent, both negative in quadrant 2, and we answer the question. Okay, that's it for this one. Go click on that other one. Moving on.